Proposition 1, Book 3. Let's do this. Okay. To having a circle, to draw the center. Let's do that. So, what we're going to do first is to connect, draw a straight line from here to there. So, we're going to do that. Then, we drew a straight line. Now what we're going to do is bisect this given the line that we have just drawn. We bisect it, so this is equal to that. Now from this line we're going to draw a perpendicular line here to the top, and we're just going to continue it down. So we're going to do that. So done. That's all. We drew perpendicularly perpendicular to this straight line, and we extend it. Now, given this straight line, we're going to bisect this whole straight line. So we're going to bisect it. Let me do that. So let's see more or less here. We bisect it. So that means that here is the center of the circle. Now we're going to make it clearer, but using reductio ad absurdum. And let's say that the center is, let's say, here. Okay, let's say that our center is here. What we're going to do is connect from this point to this point, from this point to this point, and from this point to this point. We know that we can connect straight lines, so we're just going to do them. The connect points. I mean, oh sorry, it's too thick. So let's connect them. Here, let's connect this there, and let's connect this there. So we have those three straight lines. We have just connected them. So what do we know? If this is the center of this whole circle, therefore here to here is a radii, and here to here is another radii. So radii are equal to each other. So this is equal to that. Okay. As this is equal to that, so let's see these two triangles that we have just formed. This formed, and this, and this. We see that this is equal to this is equal to this. There are two sides. We see also that the bases are equal because we bisected this whole straight line, so this is equal to that. And this third side they share, so their third side is also equal. And we have the side. Therefore, this triangle is equal to this triangle, and the angles are respectively equal. Therefore, we will have that this angle is going to be equal to this angle over here, right? So this angle being equal to this angle. As this angle is equal to this angle, and we have here a straight line and another straight line falling upon this straight line, we'll have that if this is a straight line and other line falling upon this straight line, two adjacent angles equal to two right angles. And as this is equal to that, so therefore it must be the case that this and this, these two angles, are right angles. Okay, we agree on that. So what do we have here? We said that in the beginning we were going to make this straight line perpendicular to this straight line. So if that's the case, this over here is a right angle, and this other angle over here is also a right angle. So we will have here that this is a right angle, but we know also that this is a right angle and this is a right angle. Oh, what do we have here? We see that this whole angle over here, this whole angle, let's see if I can mark here, this whole angle over here, it's a right angle. But we have that a part of this whole angle, a part of this, this whole angle, a part of this is this. And we have that this is also a right angle. So how is it possible that a part of a whole be equal, like a part of a whole be equal to the whole? That's a contradiction. And also we have the same thing here. We have that this plus this angle is equal to a right angle. But we also have that a part of this whole angle over here is also a right angle. How can be the case that is a right the part of the whole is equal to the whole? It's also a contradiction. Thus, we have shown now that we can try with all the points of the circumference of this circle, and we will still have the same thing, the same contradiction. Therefore, it must be the case that the center of this circle is that. Thus, we have shown now that we can construct, we can draw the center of a given circle. Quod erat faciendum.